So this is a short podcast on reading databases using SQL and reading the data into Python. So companies, organizations have a lot of data and they need to store it in a systematic way. For example, if you're a company, the information can be about customers' orders or the inventory. Say if you're selling things, if you're a big supermarket. So you've seen a sort of spreadsheets, Excel spreadsheets to organize data sets, but for very large companies, spreadsheets are not sophisticated enough, and you have to actually use a database. And so a lot of the sources of information that a data scientist has, or a statistician in industry, is actually a database. You have to be able to read data from a database rather than just from an Excel file. Okay, there are many different types of databases. But what we're going to deal with today is a database called relational databases. And there's a little bit of theory behind that. It was actually based on some kind of ideas from mathematics. But essentially, the idea of a relational database is it's a table. So here's an example. We have a table name, product table. Then we have a product ID, product, and cost. So this is like an inventory, say, of a supermarket or a small shop. And it's all in a table essentially, and the way we access this data is via tables. So actually with databases you access the data using something called structured query language, SQL, and this is the way you communicate with the database, either to extract data or input data. So this SQL is a standard of the American National Standards Institute, so it is actually a standard language, although many different databases systems have slightly different syntax, so it's not as standardized as it perhaps should be. So as I say, this SQL is a way to interact with databases to get information, and is actually like a programming language, but it is actually a lot simpler than Python. In particular, say in standard SQL there are no loops. Okay, so the name of the game is how to extract data from a database, and we're looking at tables. So remember, here's our example: product ID, product, cost. And say an example of a very basic SQL query is select column 1 and column 2 from table name, and that'll bring in everything in column 1, everything in column 2 from the table name. And you can kind of see that it's simpler than Python because here you actually just tell SQL what you want. You want column 1 and column 2, and the table name, you don't actually say how it does it. So the actual database stuff does that for you. There's a very good introduction to some of the syntax. We're just going to really focus on adding Python. But there is a very good tutorial here on SQL on the web. This is the web address. And there's sort of more information on select, and there are kind of written examples. So this is a good source of information for Python, for the basic SQL syntax. So below is a bit more sophisticated example. So I said the key thing in database SQL is tables. And so here we have two tables. So we have orders, say week, the date, number of orders from a farm, and then there's a farm ID. And then there's a second table for farms. And the farm table has a farm ID, and then the name of the farm, and then the acres. Usually from database design you have all these columns and rows, and one of the columns is known as the primary key because it uniquely defines the row. So here we're using the week as a primary key, and it's part of the database jargon, and it just defines it uniquely defines the row, and then you fill out the date, orders. So there is some kind of theory behind relational databases I'm not really going to discuss here. Here we've broken the information, say, of an ordering system from, say, a farm ID if there's from a farm. If a supermarket is ordering like cheese and milk and beef, say from a farm, we want to keep track of the orders. But here there's some kind of theory where you break down the information into two tables. So you have a list of the orders, and then instead of copying out everywhere the name of the farm, you have a little farm ID, and you have some information about the farm, and you separate that into a separate table. And the theory behind that is called normalization. There's a little bit of theory behind that, but essentially the idea is to have the information just in one place. So here we have two orders from one farm, and we could have written the farm name here. Instead of having a farm ID, we'd have the farm name here. We'd have Black Hallow Farm here, then Black Hallow Farm here. But one of the issues is what happens if the farm changes its name, so it changes owners or gets bigger. When you separate the information to separate tables, that means you can easily change the name of the farm or change the number of acres if it grows. And that's the area of the farm. And essentially the normalization just means one piece of information is in one place. And that means you can safely update the database without worrying about, if the name of the farm is in multiple places, you'd have to make sure if the farm name changed, you'd have to update all of them. Okay, and this in database there is something called normalization. And obviously one of the issues is because you've split the tables up, there's also some SQL syntax to deal with the fact that you have data split across multiple tables, and those things are called joins. Okay, so the name of the game is we want to really get information from a database and add it to Python. The reason why we want to do that is if you want to pull data from a database and want to do some statistical analysis, we want to plot the data, we want to be able to just access the data via SQL and then put it into Python. So normally what happens is Python will talk to a number of different databases. So sometimes a database is actually running a computer program like a server, and then you can use Python to call the server. However, this takes a bit of configuration. So what we're going to use instead is something called SQLite. This is a library that implements SQL to search the data stored in a simple file. So instead of actually the database running on a separate server, SQLite, the actual database is stored in a simple file. And the advantages and disadvantages of this database is widely used in mobile phone applications. If you want to store data on your phone. And the advantage for us of doing this is this allows us to use SQLite, allows us to get experience with SQL without the hassle of connecting to a database server. We'd have to get passwords and stuff like that. And there is more information here about the SQLite. So I believe SQLite is written in a language called C, but there's a Python interface called SQLite 3. This is a module, and you can read databases using this. So the idea is to use, so the database is stored in the file, and then we can kind of interact with it using SQL. So in principle, that should be a bit simple to deal with. Okay, so all this example will be on the DLE. So we have an SQL file in a file called supermarket.db, and then there's an example strict on the DLE called extract supermarket.py. And so the bit I want to first focus on, the actual SQL here command is select star from orders. So supermarket.db is a file and it contains a database in SQLite format. There's a table called orders in it, and this select star from orders means select all columns and rows, or the contents of all columns from the orders table. Okay, so the way it works, you first have to import SQLite 3, you make a connection to it, and then there's this kind of cursor thing, you do connection.cursor, and then you execute the SQL, and the result comes from result equals cursor.fetchAll. So just to stress, this is the SQL. Then when you do cursor.fetchAll, it returns the result from the SQL query. Select everything from orders, select star from orders. and then this result here is a list, and you can print the list out. So in this case, we've selected everything. You can also do things like just fetch one item. So here we have the select star from orders, and here we have fetch one. And in this case, we just get one row. We get the first row. Okay, so some of this code is boilerplate, and but the actual SQL command is this select star from orders, and then when you do this fetch all, you get the result in an array which you can then process. And one of the things I want to stress is this supermarket.db is a file on the file system. As we'll talk about later, you can't really read it with standard utilities, but you have to make sure that this file is in the same directory as the Python script. Otherwise, the Python won't be able to find it, and you'll get a confusing error message. Okay, so this is the output from the script. So when we select all the rows and columns, so here's the order ID. Here's some other information. Here's the date. I guess here's the farm ID. Yes, this is the number of orders, this is the farm ID, and this is the date. And you get return. And because of this, you have to do a bit more processing because this is printing out a bracket here and a bracket here. This actually thing is called a tuple, which is very similar to an array. And then the fetch one just gets the first line, like we said. So this is week 30, 100 orders, farm 1, and here's the date. So we've now extracted some SQL. So you can use this as a kind of basis if you want to do an SQL command. You can change this SQL. So you can say if you just wanted some specific information, you can just put it in, and then it goes into the array. Okay, so here's the same example, extracted data using SQL. So this time we're going to use Python to read this supermarket.db, which is a SQLite file. It has a database in this file. This will be on the file system. And this script is part of extract supermarket_date.py. So it's the same idea here. So what we're going to do is we're going to read supermarket.db, which is the file containing the database. And we want to run an SQL command. So as before, we connect to it, and then we run. So here's the actual SQL command, and here's the command select star from orders, and then you can also put conditions on it. And so we're selecting everything from the orders table where date equals 2019 4th of 15, so the 15th of April in 2019. So because of this where command, we're actually selecting a row with a specific date, and then we're fetching it back. And in this case, and here's the output of the command. So when we run this command, here's the SQL command select star from orders. So orders of the table, what date is that? When we print this thing out, we just now get just the row which matches this to 2019 415. So it matches this this date, and then we just get that row out. And then I said in the fanciful thing that this down there. So this res, when it works like that, is something known as a tuple, which is essentially very similar to an array or a list, except you can't change it. And then I have this command here, res square brackets 1, and this gets the first element. Well, it gets the first element. The second element. It gives you 95. That shows how to pull this thing out of pull this out into another data structure. Okay, so how do you create a table in the first place? So this is the command that I use to create the database. So essentially, a database is a bunch of it's a table, and there's columns, and then there's a table name, and then what we're doing here, we're creating the table. So here again, we do import SQLite 3. We make a connection. So we're now going to write this file supermarket.db. We do cursor equals connection cursor. And then the SQL command now tells SQL to create a table. So it creates a table called orders. Then there's something here. We have the column headings, the column names, week, orders, farm ID, and date. And then also we give the type. So in this case, week is an integer, orders is an integer, and farm ID is an integer. And then we have the date as a date format. So that tells the database. So this thing is a schema, and what it is essentially, it tells the database the type of the variables. And type just means things like, is it an integer or is it a date line type thing? And then this special thing here called primary key. As I said before, this one of the columns kind of uniquely identifies the row, and that's known as the key. And we can also define it here. So when we do this command here, SQL command, so this creates the table, tells it that there's a column called week, column called orders, and a column called farm ID, and a column called date. And then to insert into it, we can run the SQL command, insert into orders, week, orders, farm ID, date, and then here are the values, 30, 100, 1, and then there's a date. And then you execute it, and then it inserts this row of this information into the database. And this example's on the DLE, so you can play around with it just to see how it all works. This is an example of how to create a database using this thing called a schema. And then we're also looking at how to insert information into the database. Okay, so here's some kind of general advice about this. For any of this to work, the Python script has to know the exact location of the SQLite file. So the script, the way my example scripts works, they assume that the database file is in the same directory as the script. So if you download the SQL file from DLE, it'll usually go into the downloads folder, and then you need to copy it into the same directory as the Python script. And if you don't do that, you'll get an error message. If the SQLite module can't find the file, it will create an empty file with no tables. This is very dangerous and it's kind of slightly annoying. So if you run some of these codes, so if this code to work, you have to have supermarket.db. This is the file in the same directory as the Python script. But if you run this program the first time, it can't find supermarket.db, then it will create an empty supermarket.db file. And then when you run it a second time, you'll see that in the directory there is this file there, but it'll have no tables, and then you'll just get another error. And this has caused a lot of confusion in the past. So one of the things with the SQLite, it's in a special format which can not normally be read by standard utilities on a PC or Mac. You can install things. For small SQLite files, you can copy the file to the web page, and that will give you a simple an overview of what's in the SQL file. And this is just really for debugging. It won't work, I don't think, for very big files. I mean, the name of this game is to actually extract data from a database and process it with Python to do some statistical analysis or create a graph. So there is this utility here called SQLite Viewer, and if we look at the so if we go into work, and so here's our supermarket.db. We can't read it with any of the utilities I have on my Mac at the moment, and so we want to check that it's all okay. If we drag it into this window here, we'll see that it actually runs the SQL command, and you can kind of see what's in the file. So this is just useful when you're starting up. If you've got an SQL file and you want to see what's in it, you can drag it to this website, and it'll run some commands on it. And actually, what it is doing is actually running SQL, and you can start to see also the some of the additional syntax for SQL. So this select star from orders says select everything from orders. List limit 030 tells it just to select the first 30 rows. Okay, so this is just to help with debugging. That website here is very useful. If you have a small SQLite file, you want to have a quick check in it to make sure you understand what's going on. But remember, the goal is to read the contents of the SQLite file into Python to do some analysis. And really, the idea is, just to pull in some data from SQL and then do some statistical analysis, like calculate averages or plot graphs. So another issue I've had, if you on the DLE, I have some examples of running code to create databases in a single file. If you run the thing, if the script runs and the database file exists, it'll give you an error because it'll say you're trying to create a database file, but there's already a database file there. So what I kind of recommend is you actually kind of delete the first database file. Okay, so if you want more information on database, we'll just really scratch the surface, just give them a basic introduction to SQL. There's a good source of information about SQL at this website we looked at before from W3 Schools. It goes over some of the basic syntax. There's some good video on LinkedIn Learning. So here's the basic learning SQL programming. And these videos you can actually access via your university ID. If you log in using your university ID, it should, your university's email, it should allow you to access these videos. So this is kind of a short, well, much longer than this podcast, introduction to SQL programming. And I've also put some example scripts on the DLE. Create supermarket.py. This creates a table and adds some data. Extract supermarket.py, extract some rows from a table. This has some examples of actually running an SQL command in Python and extracting the information into Python. And then there's also this one here, extract supermarket.date. This is running SQL but saying a specific date. So it's running a different SQL query. And then also this example here, create flu database.py. And this creates a database and then adds some data to it, but it actually shows how to insert variables into a database. So you can use that as an example.